These are Lesson 8.5 notes, exponential and logarithmic equations. Today we're going to solve exponential equations using graphing and tables. We're going to first start with the graphing method. We're going to look at the equation 6 to the 4x power equals 400. Our goal is to figure out what x is equal to. We're going to try to round this value to the nearest hundredth or thousandth. To solve this equation by graphing, what we typically do to solve algebra equations by graphing is we graph y equals the left side of the equation and y equals the right side of the equation. And that's what we're going to do here. So we're going to start by turning our calculator on here, and to graph each side of the equation, I'm going to go to my y equals button here. If you have anything that's listed here under y1 or y2, you can hit clear to delete it and get rid of it. I'm going to start with y equals 6 to the 4x power. I'm going to put 4x in parentheses. And I'm also going to graph the right side of the equation, y equals the 400 number. So I've graphed both the left side and the right side of my equation as y equals equations. I want to find where these two equations intersect. The problem is when I graph this, I can see remnants of the 6 to the 4x equation just barely right here, and I can't really see anything else. So usually what I start with is in my window. I'm going to hit the window button here. This might be your standard viewing window. And we'll typically start with x min equals 0 and x max equals 10. If I need to adjust this, I will. What I usually do is I'll adjust the x max by powers of 10. So if 10 doesn't work and I need to go larger, I'll go up to 100 and then 1,000 and then bigger if needed. Or reverse, I might go to 1 and then 1/10 and then 1/100th. For my y values, I'm going to start with y min equals 0. I'm going to choose a y max about 10 to 20% larger than the constant, which is the right side of the equation, the 400 number. Since the constant here is 400, I'm going to go up a little bit bigger. You can pick 500 or 600. It doesn't really matter about x and y scales in this problem. Typically, I'll just leave them at 0. This will get rid of any tick marks that I have in my graph. So now I hit graph, and now I see my 6 to the 4x power. I see my 400, and I need to find the intersection point. To find the intersection point, we're going to go to second trace. I'm going to select the intersect command, which is number 5 on my calculator. It's going to say first curve. If I move my cursor to the right or to the left, hopefully you can start seeing my equations here. I'm going to scroll to the left because it looks like it's a pretty small x value, and eventually my cursor will end up on the screen right about now. I'm going to hit enter. Second curve, the cursor should jump to my line. I'm going to hit enter there, and then I'm going to guess about where these graphs cross. The more accurate you are with your guess, the more accurate your answer should be. We hit enter, and I got intersection point 8359750. That is my solution to this problem. So under solution, I'm going to write down x equals 0.83, we'll round this to 6. So on my calculator, I'm going to take x to the 4 times 0.836 power, and we should get something pretty close to 400, which we do. I'll also sketch a graph of this in here in the little box to verify to the reader how I got my answer. So you'll notice on my final graph I've also labeled the x min and x max values, the y min and the y max values, so the reader understands what the scale is. Let's go down to the next problem. An investment of $1,000 earns 8% interest, which is compounded quarterly. After approximately how many years will the investment be worth $10,000? This is a problem that's going to involve a compound interest formula. And our formula for compound interest is A equals P parentheses 1 plus R over N parentheses to the NT power. Now in this equation, P stands for your principal investment, which is the amount of money you start with. That's $1,000. A is the amount we end with. We know that also. That's $10,000. So I'm going to plug in $10,000, which is the amount of money we want to end up with, in for A. I'm going to plug in $1,000 for P, parentheses, 1 plus. Our interest rate is 8%, which is 0.08, over the number of times the values invested per year. Quarterly means that's 4 investments per year. Quarters, there's 4 quarters in a whole, so quarterly means 4 times in the year. 4 is also the end value that goes in the exponent, and t is the value we're trying to find in this problem. That's how long our investment is going to need to be invested for to earn $10,000. This is a tougher equation to solve algebraically. To solve it graphically, we use the same method we did last time. What I'd like you to do is I'd like you to type in 10,000 for your y1. The right side of the equation, 1,000 times 1 plus 0.08 over 4 to the 4t power on the right side. I would suggest putting your exponent in parentheses. And what I'd like you to do is see if you can find the intersection point for this problem right here. We'll pause the video and we'll go over your solution in just a moment. So when we graph our equations in the y equals menu, y equals 10,000, and then y equals the 1,000, 1 plus 0.08 over 4 to the 4x power, notice when you do type this in, the only places you need parentheses are where they're actually listed in our equation. So around the 1 plus 0.08 over 4, and then this 4x power. We're using x in place of t. And when we hit graph, you'll notice that our graphs don't intersect. So in our window, if we go back to the window we used kind of previously, I'm going to change my x max to 100. I like to go up by powers of 10. And when we do that, we should be able to see a place where these graphs actually do cross, which is right here. To find the solution again, we go to second trace on our calculator. I'm going to select the intersect feature. Number 5. First curve. I always like scrolling really close to where the graphs intersect. So our first curve is our line. Second curve is this curve. I'm going to scroll about to where it looks like they cross at, around there. And it gives me an intersection point. Again, I'm going to write down the x value. Looks like about 29.07 approximately. So I'm going to write down x equals 29.07. And then we'll sketch a picture of the graph that appears on your screen as well. And here's my finished graph, which has both the x-min and x-max values labeled as 0 and 50. And you can see the y-min and y-max values labeled as 0 and 11,000. The last thing we're going to take a look at today is how you can solve these same types of equations using a table. We're going to start with the equation 8 to the x plus 1 power equals 200. And the steps that we're going to follow are on the right side here. The first thing we're going to do is we're going to move everything to the right side, or to the one side of the equation. In this case, I'm going to subtract 200 from both sides. And that would give me the equation x8 to the x plus 1 power minus 200, notice that 200 is not in the exponents, it's kind of by itself, equals 0. So all we've done so far is subtracted 200 from each side of the equation. We're going to type this as an equation into y1. So I'm going to go to the y equals menu. I'm going to clear out my equations that were here. And I'm going to type in 8 to the, I'm going to again put the exponent in parentheses, x plus 1 power, then minus 200. We're going to go to the table set menu. This is under second window. And I'm going to use a table start of -10 and a delta table of 1. What this means is when I go to table, which is second graph, my table will start at -10 and will go up by 1s. So the values that I typed in here basically tell me where am I starting at and what am I going up by. Back to second graph again. What I want to do is that where I want to find where my graph changes, where the y1 value changes signs. So it changes from a negative number to a positive number. And you'll notice very quickly right here between 1 and 2 it changes from a negative to a positive. My goal is to find out where 0 happens. And 0 happens when our values change from negatives to positives. So I know I'm in the right ballpark here. What I'm going to do is I'm going to scroll down until I have a negative at the top, and then the next number is positive. I'm going to go back to my table, and this time I'm going to change my delta table. That's what the triangle means. It's the Greek letter delta, and it's what we go up by. I'm going to change it to 0.1, and then go second graph again. This time my values change from negative to positive here. You can see it goes negative 18.98 and then 22.861. I'm going to scroll down under the x values until these two values end up at the top of my screen. Negative followed by a positive. For the last time, I'm going to go to second window. I'm going to change my delta table to 0.01. Hit second graph. And the closest thing I get to, well, first of all, it changes from a negative to a positive, going from 1.54 to 1.55. The number that's closest to 0 is the number I'm going to choose, which is 1.55. I'm going to write that down as my solution. And you can verify your answer by trying it out in your calculator. I'm going to go 8 to the, if I do 1.55 plus 1 power, this should give me something close to 200, which is what I get. We're going to try the same thing for the other equation as well. I'm going to type in, here I have 4 to the x minus 6 power equals 10x minus 4. If I subtract 10x from both sides and add 4 to both sides, basically everything on the right side of the equation will cancel, and I'll have 4 to the x minus 6 power minus 10x plus 4 equals 0. We're going to do 4 to the x minus 6 power minus 10x plus 4. And again, I'm going to start by going to second window. We're going to do a table start of negative 10 and a delta table of 1. I'm going to hit second graph. I'm going to look for where my values change from negatives to positives. So it looks like right here between 4.00 and negative 5.99. So I'm going to scroll along my x's to the bottom until these two numbers are my first two values listed. I'm going to go back to second window, change my delta table this time to 0.1, go to second graph. I'm going to look for where my values change from positives to negatives. That seems to happen here to here, from 0.5 to 0.4 to 0.5. So I'm going to scroll down to those values that are at the top of my screen. I'm going to go second window one more time, change my delta table to 0.01, second graph, and it looks like they change between 0.4 and 0.41. Which of these values is closer to 0? Actually, this value right here, 4.3 times 10 to the negative 4th power, is like 0.00043. That's my closest value. So 0.4 is my solution. Now, what's interesting is that some problems may have more than one solution. Now, I'm going to go back to my original table start, which was negative 1, and I'm going to change my delta table. I'm going to change my table start to negative 10 and my delta table to 1. I'm going to go back to my second graph. And you'll notice that not only do we see a sign change here, going from 4 to negative 5.99, but if I continue down my table, there's also a sign change that occurs between 9 and 10, negative 22 to 160. Let's take a look at where this one is. I'm going to scroll down here, so I have x equals 9 and 10, so my negative number changing to my positive number at the top of my screen. Change once again my delta table to 0.1. Second graph. Okay, there's my sign change, negative 3.551 and 8.059, so we'll scroll down again. Second window, delta table 0.01. Second graph, and the sign change happens between 9.23 and 9.24. The closest value to 0 appears to be 9.23, so we'll write that down as an additional solution as well. So double check on these types of problems because there may be more than one solution. If you follow the steps, I think you'll be in good shape.